Good afternoon. My name is Carolina Diaz Garcia. I'm gonna cut all the introduction because we have. Sorry. We had this afternoon a whole masterclass about PFAS, so we are gonna finish early. So, land application of effluents on biosolids from wastewater treatment plants. It's been used widely because we mentioned before, recycling nutrients, improve the soil health, and reduce the fertilizer. Yeah, sorry. Also, because of the cost, many of the times are free, so it's a good advantage. But the problem is like wastewater treatment plants has a limitation. They are not designed to remove emerging contaminants. So sometimes people need to choose between sustainability and risk. Among these contaminants, emerging contaminants, we have the PFAS. Well, they are important here because they are persistent, they have a lot of mobility, and they can move easily through water and soil. Also,
we're having a Zoom problem. Can we see it now?
yes. Well, thank you, Beth and Filsa, for all this help. Well, I was mentioned that we mentioned before, previous presenter, like the wastewater treatment plants pass the PFAS through the effluents of the biosolids, and in different pathways they arrive to our agriculture and to us. So how we translate this to a real system. So in a town near here in Illinois, we analyzed the water from the wastewater treatment plant. Is based in 3 lagoons. So we analyzed the different lagoons, as you can see there. And the thing of this town is they use that effluent to irrigate a nearby field. So in that field, they have soybean and corn. So we also analyze the groundwater in those fields to know the whole path, how we are in the wastewater treatment plant and how are in the wells in the field. Also, here we have the irrigation system. Dr. Waysen taking samples. He is there today too. So we are here. And so also before and after harvest, we take plant samples and soil samples. We only have samples from the plants from the spring of 2025 because this ground was cut with those problems with the APA project. But we will continue. So here we are going to jump directly to the results. So here we can see the results from the lagoon. We have from Lagoon 0, that is the influent to the wastewater treatment plant, to Lagoon 3, that is right before the effluent. So we have the concentration in nanogram per liter, and we have the spring and the fall on 2025. So we notice that along the 3 lagoons, the concentrations are similar, are below 120, but we can say that there is no reduction of the PFAS among the lagoons. Another thing that we can mention is like these concentrations are in the average of the wastewater treatment plants effluents that other studies has analyzed before. The main PFAS that we saw here were GenX, PFOA, PFOS, and PFHXA. After the Lagoon 3, that water is used to irrigate the groundwater. So we analyzed several wells, also during the spring and the fall. And we also analyzed the drainage water. We only have data from the spring because when we sample in the fall, there was no drainage. I forgot to mention, but we sample all these lagoons and wells once a month. Here we have that the concentration are pretty low. We only have between 4 and 9 PFAS in all the wells. The average, the concentration are inside of the previous studies from other locations around. As I mentioned, we also take the soybean and the corn, and we analyze the leaves, the stems, the grain. So we are going to focus first in the soybean. So here we have the results from the 2 fields that have soybean. We can see that the leaves were higher than the stems, but even with all the results, even with the grain, the concentration were really low. And also are similar to other studies. Okay. If we move to the corn, we can see that the results are in the similar levels. And the only thing that we need to, or we want to do here is keep taking samples, because this was from one time. We had 2 more years of the study, so we can complete all this information. For the soil, we analyze and we detect PFAS, but the problem was really, well, not a problem, was really good, was a really low concentration below the LOQ. So now this was all the results when the water is the effluent. From the wastewater treatment plant, we have the water, the effluent, that we saw one example in a town near here. But the solid part, the biosolid that we were talking before, is the other problem. So we also did a different experiment. In this case, we analyzed 5 different biosolids from 5 different wastewater treatment plants around Illinois. Here is a mix between small towns and big cities. So. But all the results are pretty similar, below 150, which are inside of the average concentrations around other studies. With these results, we took one of the biosolids. We tried to mitigate, to do an experiment to reduce that PFAS concentration, that leaching. So here we use designer biochar. Dr. Wei is well known for this. He's designing biochar. In this case, was with iron, and we mix biosolid with different percentage of biochar, 5, 10, and 20, 5, 10, and 50%. So we analyzed 2 short chain PFAS and 2 long chain PFAS. We are going to see the result one by one. So we are going to focus first in the PFOA. So we have in the y-axis the cumulative PFAS leaching, and on the x-axis we have the desorption, the washing time. We were washing the biosolids during 7 times. The results show that as higher percentage of biochar mixed with the biosolid, the leaching was lower. You can see that the line is on the bottom, is here. They were not leaching for 50% of the 50% biochar inside of the biosolid, and for the line that the biosolid were no biochar was the higher leaching. Similar results were for the PFOS and PFBS, and the pattern is the same for the PFBA, but we know that this is a more difficult PFAS. For 50% of the biochar, we have some leaching. And this is because the short chain has more mobility, it's more difficult to keep retained in the biochar. So we are working on that. So as a takeaways, we have the PFAS. We can detect in these samples that we have in the field. All the PFAS from the plants are going to the field, but in really low concentration. So the biosolid is something that we need to attack. We saw before with that concentration, crazy concentrations. And we are still working with trying to reduce the leachings of PFAS with this design biochar. Thank you so much. This was funding for an EBA project.
Questions for Carolina?
Hi, thanks for the presentation. It was wonderful. Do you have any sense of when you were looking at the plant uptake of PFAS, or even just in the soil on the farm? Maybe you mentioned this. I'm assuming that the farmer was using chemical inputs that could contain PFAS themselves. Were you able to separate those two things to see kind of what came from biosolids and maybe what came from another source?
Not for this time, but we are planning to do in a follow-up time to know when they plant and try to follow all the process that they, to be able to separate that when they plant and everything.
Thank you. It seems that in this particular field they were not applying biosolids. Is that correct?
No, they don't apply biosolids.
Just think it'll be interesting if you can find another place where they're applying them, so you could play this same game and then see, as you mentioned, you're sampling monthly. If over time those biosolids, what happens as they incorporate with the soil, and then what happens to those PFAS and the concentrations.
Yeah, and I know in Michigan they have a lot of legacy of the biosolid from many years, and they are doing that, and yeah, that should be great. Yeah. Now we are working in another EPA project that also we are applying biosolid with different percentage of biochar in the field. So we are doing a big scale. This was a smaller scale. Not the same, but
Thank you.
In one of your earlier slides, you showed the wastewater, the intake, and the level in the fall was a lot lower than in the spring, I think. Do you know any ideas of what's driving that, or if it's just being driven by sort of variation in the points?
So can you repeat? It's like in the
Yeah,
in
if
the
you go to
fall-
your earlier,
in the
I
fall
think it's
was
your first
lower?
results slide.
Yeah.
Yeah, so I was just looking in the first, the location 0, the inflow, it's a lot lower in the fall.
Yeah.
If that's just, I guess I'm looking at the scale now, it's not, I guess 40 versus 120, so
Yeah.
3 times. Do you think is that being driven by one of your monthly sampling points, or do you have any reason to think there actually is a seasonal difference?
So we need to keep analyzing because this project was cut. So we will have more data, more accurate data in the future. But I can.
To be determined, yeah. Awesome. Any other questions? Oh, one in the back.
I have a question from online. Yusra asked, thank you for the great presentation. Why choose biochar and not activated carbon?
Well, we are doing a lot of experiment. We designed a biochar trying to find something cheaper than the activated carbon. So we are doing a lot of modification with different biochar, different materials, basically, because we are trying a lot of things. So the goal is to find something cheaper than the activated carbon.